So we have multiplied and divided rational expressions. That works just like multiplying and dividing fractions. Next, we'd like to add and subtract rational expressions. And in order to do that, we'll need to review how we add and subtract fractions. Now, we can add and subtract fractions that have the same denominator. Remember, the denominator of a fraction tells us what kind of thing we're talking about. When we're talking about the same kind of thing, we can add and subtract by just adding and subtracting how many. In other words, if we have the same denominator, we can add and subtract fractions just by adding or subtracting the numerators. If we have 5/9 plus 7/9, the denominator stays 9. We add the numerators, 5 plus 7, and we get 12/9. We're done adding, but the instructions say we have to simplify, which means we need to cancel any common factors. It looks like 12 and 9 have a common factor of 3, right? 12 is 3 times 4. 9 is 3 times 3. And so we get 4/3. When we subtract, the only difference is that instead of adding the numerators, we subtract the numerators. So if we have 9/8 minus 3/8, denominator stays the same. Numerators we subtract. So 9 minus 3 is 6, and we get 6/8. Again, the instructions say we have to simplify, and I think 6 and 8 have a common factor of 2. So we get 3/4. Okay, so if our fractions have the same denominator, adding and subtracting is easy. Just add or subtract the numerators. If we don't have the same denominator, we can't add or subtract. So if we have fractions that aren't presented to us with the same denominator, we have to rewrite them so that they do have the same denominator. If we have fractions that are presented to us with different denominators, there are 4 steps to adding them or subtracting them. First, we need to find the least common multiple of the denominators. Right? A common multiple means each denominator is a factor of the denominator we want to come up with. Then we write equivalent fractions that have that denominator. We add these new fractions, which now have the same denominator. And finally, we simplify. So in this example, we're going to add 5/6 plus 7/10. And these are nice small numbers. There are a lot of shortcuts that we could use to get us to the sum of these two fractions, but I'm not going to use any of the shortcuts because my goal is to be able to apply the same techniques when, instead of being small numbers, my denominators are polynomials. So I'm going to find the least common multiple of 6 and 10 by looking at their prime factorizations. Right, so 6 is 2 times 3. Those are prime. 10 is 2 times 5. Those are prime. So 6 is 2 times 3. 10 is 2 times 5. My least common multiple needs to have a 2. It needs to have a 3. And it needs to have a 5. So if I multiply that out, that's 30. And we can confirm that that's a common multiple, right? 30 is 6 times 5. 30 is 10 times 3. But for reasons that will become clear in a moment, I'm not going to use 30. I'm going to actually use 2 times 3 times 5. I'm going to leave my denominator factored through this whole process. And we'll see why as we go along. So 5/6, that's 5 over 2 times 3. And I want to write that as something over 2 times 3 times 5. Well, the missing factor is 5. So I need to multiply my numerator by 5. And so I'll have 25 over 2 times 3 times 5. 7/10, that's 7 over 2 times 5. And I want to write that as something over 2 times 3 times 5. Here the missing factor is that 3. So I need to multiply by 3 in the numerator as well. So here I'll have 21 over 2 times 3 times 5. So 5/6, that's 25 over 2 times 3 times 5, plus 7/10, that's 21 over 2 times 3 times 5, equals 25 plus 21 over 2 times 3 times 5. Actually adding 25 plus 21, I get 46 over 2 times 3 times 5. So now I'm done adding. Finally, I want to simplify that. I've got 46 over 2 times 3 times 5. My denominator is still factored. I just need to factor my numerator. So I've got 46. Well, 2 goes into that. That's 2 times 23. 23, I can go through and try dividing by all of my small primes. It turns out that 23 is also prime. So I've got 2 times 23 over 2 times 3 times 5. The common factor of 2 cancels out. I've got 23 over 3 times 5 is 23 over 15. And notice how I left that denominator factored. I would never have had to find out about 30 anywhere in this process. I would never have had to do that multiplication of 3 numbers. With 3 numbers, of course, that isn't a big deal. We don't care very much. But multiplication of 3 polynomials, well, that's kind of tedious. So the fact that we never need to find out what the actual product in the denominator is, that's pretty nice.